So graphing linear inequalities is our topic today. We know what linear equations are, but what are linear inequalities? Well, what are inequalities? Have you guys heard of inequalities before?
Yep.
Yeah? Like, have you heard of inequality symbols?
Yep.
What are inequality symbols? Who remember? Raise your hand. Who remembers? Yeah.
Greater than, less than.
Yeah. So greater than, less than, less than or equal to, greater than equal to. So keep that in mind, because we're going to be graphing this linear, not equations, but graphing linear inequalities. And let's see how different that is. Okay? It actually has very close relationship with graphing linear equations. So you guys remember how to graph linear equation this way? Y equals to x plus 3. Do you all know how to graph that? Yeah, we all know how to graph this. So write this down and think about what the graph will look like. And we're going to graph this in a minute. But what I wanted to ask is, the graph of this linear equation y equals to x plus 3 does something to this coordinate plane. So hold on, write this down first. So what does it do? Well, can you fill in this blank? The graph of the linear equation y equals to x plus 3 separates the coordinate plane into something blank set of points. So you could think of coordinate plane is set of points. That coordinate plane is made up of a bunch of set of points, right? When you graph this line, y equals to x plus 3, right? It separates the coordinate plane into how many sets of points? Anybody? Anybody have any guess? Yeah. 2. What do you say 2? Okay, why? Why did you guess 2? Why not 1,000 or? Oh, so you're looking at the two variables x and y. That's not the reason why. It is not 2.
No.
Yes, Sarah? In 4, why do you say 4? Oh, 4 quadrants. Okay, but I'm talking about if you were to draw this line on a graph, okay, it actually separates, you could kind of group these set of points as points on this line and all the points that are above this line or all the points that are below this line. So it separates into 3 set of points. And I wrote down here. You could think about the points, okay, the points on the line, which is, of course, points on the line is represented as y equals to x plus 3, right? That's the line. You could talk about then all the points that are above this line and all the points that are below this line. Can't you not? Do you know what I'm talking about? So I even have a little picture for you here. You see how nice? Look, I used color. Yeah, I even used the colors that I normally don't even use. Anyway, so the points that are on this line, this is the black line right here. You see the green? Well, no, not green. That's not green. But blue, light blue is above the line, and the purple is below the line, right? Doesn't it separate into 3, right, set of order pairs? In other words, if I were to pick a random point from this coordinate plane, that point will be either on the line, above the line, or below the line. Okay. By the way, this line is called, we'll get there in a minute. So, any question? Does this make sense?
Yeah.
Okay. Now, yes, Alvin.
Is this the one that you have to line and you have to color the?
Yeah. Okay. So some of you have seen this before in intro or 6th grader. Now, what then? How would you represent then? Because I don't want to always say, oh, you know all this. So if I wanted to represent every point that is above this line, I don't want to say the whole sentence. The points above this y equals x plus 3. There's a nice way to actually write this mathematically. Do anybody know? Yeah. What do you think?
Y is greater.
Exactly right. All the points that are above this line is y is, let me just, greater than x plus 3. Isn't that nice? Rather than me saying all the points that are above this line, we could represent, right? It's just saying y is greater than x plus 3. If that's true, then what do you think we could use, what do you think we should write for points that are below this line? Anybody want to take a wild guess here? Yeah, Sarah? I mean, huh? No, it's not. She's not Marisa. Oh, oh, you Marisa? My bad. I thought you were trying to. Okay, go ahead.
Y is less than X.
That's right. Y is less than. Oops. Y is less than. Oh, Y is less than X plus 3. Right? Isn't that nice? So rather than saying, oh, all the points that are below the Y equals to X plus 3. Okay. So that's what we do. We have a nice way of representing all these points that are either below, above, or on this line. By the way, this line, y equals x plus 3, you know the points that are on this line, y equals x plus 3. There's a special name for this line. Anybody know what this is called? This line is called the?
Boundary.
Yeah, boundary line. Boundary line. What do you think it's called the boundary line?
Because it's a boundary.
Separate.
It separates the what? All the points that are above the line and all the points that are below, right? It sets a boundary between these, right? Points that are above and below. So it makes sense why they call it boundary line. Okay. Any question? Does this make sense?
Yeah.
It's pretty easy. All right. Okay, let's move on then. Graphing linear inequalities. You know, the equations, instead of equal sign, you have greater than or less than, or greater than or equal to, less than or equal to, these inequalities. How many symbols do we have for these inequalities? You have 4. So we have 4 cases to think about. So first case, as you may have expected, oops. First case looks something like this. When you have y that is greater than x plus 3, as you can see, you could have dotted line. Why do you think I have dotted line instead of solid line for my boundary in this case? One person see it? Okay, wouldn't it be above this line, right? Y is greater than x plus 3. So here's my boundary line. That's what you graph first, right? You graph your boundary line and it's going to be shaded above. Why do you think I have dotted line? Yeah.
Because the line doesn't count.
Exactly right. What do you mean by line doesn't count?
Like for y is greater than x plus 3, if nothing on the line.
That's right. It doesn't say y is equal to x plus 3 also, right? Does that make sense? So therefore, any point on the boundary line, would that be my solution to this inequality, y greater than x plus 3? No. In other words, is 0, 3 a solution to this inequality? 0, 3 will be a solution? The 0, 3 is on this boundary? No. What about 0, 4? Would that be
Yes.
my solution? Yes. Okay. 0, 4 would be right here, wouldn't it? It is a point on the y-axis at 4. Is that point a solution to this inequality? Y greater than x plus 3? Yes, it is. It's on that shaded region, right? So every point on this shaded region is a solution for y greater than x plus 3. That's what this means, right?
Well, like, if you like did like y equals like, wait, what did you say it was 1, 4?
Yeah, 0, 4.
Oh, no.
Okay. All right, then what do you think the graph of y less than x plus 3 might be? That's my second case. Go ahead and graph it. What would y less than x plus 3 be? I'll give you some time. Go ahead and graph and see if you can figure it out. Of course, you could help each other out. So what I want you to do is, guys, you see how I graph the y greater than x plus 3? There are 4 cases, as you can see. Another case could be y less than x plus 3. The other could be what? Y greater than or equal to x plus 3. And you could also have y less than or equal to x plus 3. Can you graph these 4 cases and see what the difference will be? Okay, go ahead and graph these. Well, how would they look different? Do you understand what I'm asking you to do?
Well, you want us to graph all of it?
Yeah, I want you to graph all. So there are three other cases now. We did one. Go ahead and graph. And I want you to understand the difference between these 4 cases, what the difference is. Okay, go ahead, everybody try. Okay, so those of you that graph y less than x plus 3, how does that look different than the first case here? All 4 cases look different, don't they? Kaylin, what do you think? How can you describe for me what this looks like? Y less than x?
So y less than x plus 3 is with the dotted line and the shaded line.
That's exactly right. So of course, when the process in which you graph this is you first graph the boundary line, right? Which is y equals x plus 3, right? But then you need it dotted. Very good. And it's going to be below. Does that make sense? Easy, guys? Okay, then how would this be different? Y greater than or equal to x plus 3. Sarah? Is that one going to look different than any one of these two? How so?
It would be a solid.
Yeah, instead of dotted line, it's going to be solid because now we are including the boundary line, are we not? And it's going to be shaded below or above? The boundary line. Above, it says greater than. Do you guys see the difference? So it looks very similar to the first one, but then now we have to include the boundary line, right? Does that, you understand? And the last one, of course, is going to be, it'll look very similar to y less than x plus 3, but what's the difference? Only difference is now the boundary line will be solid. Does that make sense? How many got all 4 of these correct? Does this make sense?
Yes.
So you could have 4 different cases, even with the same boundary line, right? Depending on whether or not, depending on what kind of inequality symbols you have, right? You will have dotted lines or solid lines, depends on whether or not it's strictly less than or strictly greater than. If you have less than or equal to or greater than or equal to, the boundary line will be what? Solid, right? Does that make sense? Okay. Any question? Easy? Alright, so let's see if you guys remember this rule for inequalities. There's one rule when you are dealing with inequalities that you have to remember. Like, for example, if you have to solve for one of the variable in inequalities, you have to be careful. It is really very similar to solving for a variable in an equation, but you have to remember one fact about these inequalities. Does anybody remember what you have to be careful of? Nobody remembers the fact? Yeah, okay, let's see if it rings a bell. Here's a fact. When you multiply or divide the both sides of the inequality by negative number, what happens to the inequality symbol? Yes, sir. You have to reverse the inequality symbol. You guys remember this? This is one fact you have to really remember when you're dealing with inequalities. Otherwise, you're gonna do this wrong. For example, think about this. Example 1. I have 2 and 5. Which one is greater? 5. Let's divide both sides by negative 1. What do you get when you divide 2 and 5 by negative 1? If you divide both sides of this inequality by negative 1, is right side still greater? No. Right? You get negative 2 and then negative 5. Which one is greater, negative 2 or negative 5? Negative 2 is greater, isn't that right? Is negative 2 on the right side of negative 5? So it's negative 2 is greater. You see, if I would have kept this inequality symbol as it was, right, would the statement be true? No. That's why you have to reverse this when you divide or multiply both sides of this inequality by negative. You guys remember this? Let's see what happens when you divide. Here. I got 4 and 8. Let's divide both sides by negative 2. Would the right side still be greater? No. You have to then, therefore you have to reverse the inequality symbol. You guys remember this? Yes? What if I divide or multiply both sides by positive number? Does it do anything?
Nope.
No, it stays the same. Here's an example. So, right? If I have 2 and 5, if you multiply both sides by 2, still right side is greater. If I have 4 and 8, if I divide by 2, still the right side will be greater. What about addition and subtraction? Do we even have to worry about those? No, it doesn't matter. If you add or subtract same number to an inequality, whatever there was greater side, it'll still be greater, right? It doesn't change. Only time it changes when you have what? When you are multiplying or dividing by what kind of number? Negative number. Okay? Does that make sense? You guys remember this? So knowing this, let's do a problem. It says graph this inequality. Go ahead, everybody try. How would you graph 3x minus 2y greater than or equal to negative 4? By the way, do you like this form as it's written right now?
Yeah.
No. How should you change this to? Slope, intercept form with inequality, right? Does that make sense? That way you would know your slope and the y-intercept, right? Go ahead, everybody. Go ahead and see if you can do this one. Don't graph it yet. Just give me the slope-intercept form of this inequality. Is that okay? Yes? Go ahead, everybody try. We'll graph it together, okay? So, were you able to solve for y? What should I do in order to get the y by itself? To write into the slope-intercept form, Lucia?
Minus 3x.
Yeah, subtract 3x from both sides. Then you get negative 2y greater than. Now, does that reverse the inequality symbol at all by subtracting 3x from both sides? No. But now, when you're dividing both sides by negative 2, did you all remember to reverse the inequality symbol? Yeah, how many people remember to reverse it? Raise your hand.
I did it by accident.
You did it by an accident. Okay, so when you're dividing by negative or multiplying by a negative number to both sides of the inequality, you must reverse it. Otherwise, it will not be true anymore, right? So, were you able to graph and get this graph?
Yes.
You start at 2, right? You draw your boundary line, go up 3 to the right one, or you could go down 3 to the left 2. Then, to the right 2, right? Go up 3 to the right 2. Then you shade it below. How many people got this graph? Raise your hand. How many people see now why this is the correct graph? How many people put the boundary line as dotted line? No one did that? Okay, good. It's going to be solid, right? Did anybody shade it above? Okay. Do you see why it's below? It shouldn't be above the line, would it? Right? You have to shade below the boundary line because every point, every order pair below this boundary line is, right, your solution, right? Aren't they all those points are your solution? We good? Any question? Should we try a couple more here? Okay. Why don't you try this one then? Y is greater than 2. This is one of those questions where people mess up, even though this is one of the easiest questions to do. How would you graph y greater than 2? Go ahead, everybody try. All right, how about, let me ask, Brian, what would I do here? What's my boundary line, first of all? Right, it's going to be a horizontal line. What's the equation of the boundary line, guys, by the way? What's the equation of this boundary line? Y equals to 2. So you just replace the inequality symbol with the equal sign, right? So y equals to 2, isn't that my boundary line? And it's a horizontal line. You could do a little table. Y is always equal to 2, right, Alvin? And so you could have any axis you want. So it's going to be a horizontal line. Viviana, do I shade above or below this? Above? Why do you say above? Yes, that's y is greater. So there you go. And did you all put dotted line for y is equal? Okay. Very good. Can I give you another one? Is this pretty straightforward? Okay, good. Let's look at example 3 then. Go ahead. Try example 3 here. Now, this one's a little bit different. It says x is less than negative 3. Okay. So what would you do on this one here? Go ahead. Everybody try. So, okay, William, what should I do on this? What's the equation of my boundary line, first of all? X equals to negative 3 is correct. And so what kind of line is x equals to negative 3, class?
Vertical.
It's a vertical line, very good. And if you're not so sure, you could do a little table, right? X is always negative 3, that's what it says, right? X is equal to 3. Y could be anything you want, because it doesn't tell you anything about y. You could choose any y's you want. Therefore, it's a vertical line. Now, this time, since it's a vertical line, you can't shade it above or below. What do you do in this case? Allie, what do you think? I can't shade it over below for a vertical line, can I? What should I do then? Yeah, you should shade left or right. Which side should we shade? Left. Why do you say left? Well, it says x is less than negative 3, right? So we're looking for values that are less than negative 3. Where are all the values that are less than negative 3? On the left of 3 or right side of 3? Left. So therefore, this is a graph, right? Does that make sense? So this vertical line separates this coordinate, right, plane into 3 pieces, 3 set of points, one on the left or right, or on this line. So we're looking for all the points that are on the left. Okay, does that make sense? Any question? This is pretty straightforward. Good.